Section 7.1, Chapter 7, Statistics. What I did here, I summarized all the formulas of Chapter 7 into one page. So when you want to work on the problems, then these are the formula to use. So section 7.1 is dealing with this formula. And this formula, it finds range for proportions. And there is a formula for margin of error. This is a formula, and this is how to find the sample size. So as I go through the example, then I go back to this page and show you how to use the formula. All right. Here, there are some terminology that we are using here. One is a confidence interval, confidence level, and here is some numbers that we apply in the problems. All right. Again, we understand all this when we go to the examples. Now, as far as the confidence interval, let's look at these problems here. We must be careful to interpret the confidence interval correctly. Confidence interval, look at here. 0.95 or 95% confidence interval estimate of population proportions. Let's say we go to one place and one large area and we find proportions, for instance, proportion of family's income. And we find out that for that population's proportion of family income is always between 87 and 82%. But when we interpret this data, we got to be careful and interpret it correctly. So when you have proportions less than 0.872 and greater than 0.828, like inequality, then the correct way of interpret this is we are 95% confidence that interval from 0.828 to 0.872 actually does contain the true value of proportions. It's incorrect if we say there is 95% chance that the true value of population will fall between these two numbers. And that's another correct, incorrect way of saying it. Let's assume that there is a large city and the proportion of population's income, it's always between, let's say, 87% to 75%. This is for the populations, okay? Well, let's say we don't know that. This is unknown, okay? So what we do is we go ahead and take a sample from several places and we do some calculation that we have in these sections, and then we come up with something like this. we come up with several estimate or range. What we're saying is 95% of this interval does contain, or they are close to the actual proportion of populations. All right. So that's what they have here in these examples. That we came up with 20 intervals. And out of these 20, 19 of them contain the actual value of populations. Let's say if it's 90%. So then we say this is 95% success. It's just like one does not fall into that category. So this is definition of confidence interval and what that is. Now, on chapter 3, there was an example of here that I kind of exaggerate this example. A couple want to have 20 children. What's the probability when they want to have a girl? What's the probability of none of the 20 is a girl? Is basically 0. One of the probability of 1 out of 20 is a girl. 2 out of 3. So you see the probability is extremely low, and as the number increase, probably getting better. So probability start rising, reach to a peak, and then drop. Like what's the probability of 15 out of 20? Oh, I'm sorry, the 10 out of 20 are the girls. Very good. See, it goes to the peak and then drop. What's the probability of 14 out of 20 are the girls? Probability start dropping. What's the probability of 16 out of 20 are the girls? Probability to drop. So there are two critical zones. And that means lower than these numbers and higher than that number is almost impossible, is unusual. How do I find these two numbers? Remember when we find mean and standard deviations, and then it would be mean plus or minus 2 standard deviations. When we find these 2 points, then any number greater than that, like in this example, we figure those numbers are 14.4 and 5.5. So any number greater than 14.4 is unusual. Any number less than 5 is unusual. So if you say, what's the probability of 4 out of 20 is a girls? You say it's unusual because it falls here. So these are critical zone. All the numbers that, all the probability that fall between these two are okay, they're usual. And then when you graph it, like in these examples here, you see 5.5 and 14.5. So any numbers greater than 14.5 and less than 5.5 fall into the critical area, which is the unusual value. How do I get the curve? When you have all the bar graph or a histogram, when you connect the top of all this rectangle, then you came up with a curve. All right. So based on that, now we have finding a critical value. So when we say 95% confidence level, means this area of the curve is 0.95. Remember, the total area under any curve is always 100% or 1. So if this area is 0.95, how do I find area of these two tails? These are tails. Tails are two areas that are both equal to each other, and those are critical area. how do I find these? 1 minus 95%. So look, if you have here, if this is 0.95, and you want to find this too, and the entire area under the curve is 1, then you say 1 minus 0.95, that's 0.05. 0.805 is area of two tails. We call it alpha. Alpha is area of two tails. But if you want to find area of each, then you take that and divide by 2. That gives you area of one tails. That's why here we have z of alpha half. Z of alpha half means find the z for alpha half. Now, if you have, let's say you have standard curve and you want to find the z value here when the area is 0.025. There are two ways to do it. One is to just go to the tables, table A2. In table A2, these are all area. These numbers are all area, right? You find 0.025, then you read the z value. Or it's easier to use the calculator. You go to the second verse, and then inverse norm, and then you put 0.025. That gives you this value here. So you go to the second verse. Number 3 is inverse norm. You put that number, 0.025, I had it already. Minus 1.96, okay? So that means this point is minus 1.96, and the other one is the same, is just positive 1.96. So all I need to do is just find one of them, which is a negative, and the other one is positive, okay? So now here, they have done some of the calculation for you here. Like here, it's they're saying for 90%, for 90%, alpha is 0.10 and 1.645. See? Um, 90%. 90% confidence interval. The total area again is 1, so it's 1 minus 0.9. It's 0.1. 0.1 is area of two tails. We say alpha. Alpha is area of two tails. What is area of one? That is area of each tails, or alpha half. That's why here you put z of alpha half. That means this z is for this. Now, let's calculate that one now, the z of alpha half for this point. So again, you either go to the table, go to table A2 and find 0.05 and do it this way, or just go to the calculator and just say second verse inverse norm, put that number, and the calculator would give you 1.645, right? So this one is negative 1.645, and the other one is positive 1.645. That's how you calculate when it's a 90% confidence interval, and also for all of them. The ones that are most common are here, 90, 95%, and 99%. See, I show you some examples here. When it's 95%, you either go to table A2, when you go to the table A2 is like this, look, see that? Like, let's say here for 0.025, 0.025 is here. If you want to use table A2, you just go here and there, and that would be minus 1.96, right? Or you go to second verse inverse norm, and then you put that number 0.025. When you hit, it give you minus 1.96. Okay, so these are the typical number that we normally use in the problems. 90%, again, you subtract it from 1, divided by 2. %, subtract from 1, divide by 2. 99%, okay? So normally you always use one of these 4 numbers for the problems. Now here, we want to go over these examples here. Find the margin of errors E that correspond to 95% confidence level. So what they have in this problem is this. They give you, we know the n value. P hat is proportion of the samples. They call it proportion of samples. And of course, Q hat is always 1 minus that. So first we have to find the margin of the error, E. You know, in real life, when we, let's say you get it, you know, you apply for a position and they give you an offer for that particular positions, and you want to know what the salary is for that classifications. They say the salary is 42,000 plus or minus 3,000. So they say the salary for this position is 40,000 plus or minus 3,000. This plus or minus 3,000 is the margin. Means what they're saying is this: the salary of these positions is always between 40 plus 3,000 and 40 minus 3,000. Okay, so it's what? 43,000 and $37,000. That's the salary. So that's what we're trying to do in this problem. Here we are doing proportions is always between P hat plus E and P hat minus E. What is this E? E is margin of the error that we always add or subtract. So E is from this formula, Z of alpha hat, P hat, Q hat, N. What is Z of alpha hat? Means just these numbers. Remember, here is alpha half, and this one is Z of alpha half. Z of alpha half means this number because it's designed, this Z designed for a half of the alpha. So you take all those and put it here. It's 0.025. Then you take that and add it to proportion of the sample. Now, there is a way also to use the TI-84 or TI-83 calculator to do that. But the calculator requires these informations. You need the X, you need the N, you need the confidence level. We have the confidence level is 0.95 or 95%. N is given, but X is not given directly, right? But we understand that P hat is X over N. Let's say here there are 5 red balls and 3 green balls. There are 8 balls into one basket. What is the proportion of green when you take one? Green is 3 out of 8. 3 out of 8 is green. That's what P hat means. Okay? And what is Q hat? How many are left? 5. 5 out of 8. That's why we always subtract it from 1, because 3 hat 8 plus 5 out is 1. Okay? So here, if you want to use the calculator requires X. So I have to do a little calculation because X directly is not given in the problems. In the problems, P hat is given, N is given. So you multiply these two to find your X. X also has to be a whole number when you want to put in the calculator. So when I did the calculation, it ended up to being 639.41. So I kind of rounded to 640. So when you place all those numbers in the calculator, then you go to test, then find 1 dash proportion Z interval. It gives you that. It's very close to the actual number. So So that's how to use the calculator and how to do the hand calculations. This example is, they're telling you that how to find a p hat and e hat if both are given. Like here, we know the formula is capital P is always between p hat plus e and p hat minus e, right? Let's say you have the answers already. You know that this one is between 81% and 58%. You already have these two numbers. It's given in the problems. They ask you to find p hat plus e. I mean p hat and e hat. So you understand that p hat plus e is 0.81 and p hat minus e is 0.58. Now this is two equations and two variables you need to solve. So this will cancel, is 2e is 0.81 plus 0.58. And when you divide it by 2, that gives you the p hat, which in this one they came up with 0.695. When you find it, then you could just use the top equation. You know that p hat plus e is 0.81. So you already have p hat is 0.695 plus e is 0.81. And that gives you the value of e that they find it here for you, 0.115. Okay? So this is the type of problem that you already have the answers and you want to find the confidence, you want to find p hat and margin of the error. Now, sometimes they ask you to give us the number of samples. See, most of the problem that I did so far, we know how many samples are we taking. And we also know the n value. What if the n value is unknown? Then you use this formula here. If p hat and q hat and margin of error are given, so you go ahead and put all those. If p hat is not given in the problems, normally we assume 50% or 0.5. We see that when you go to the examples. So n, the number of samples, is not designed in the calculator. You have to do the hand calculation for that. And this is a solution for it. See, remember how I show you to use a calculator, and the calculator is not for sample size. But if you want to find a confidence interval, you go to stat, proportion of z, one sample. This is how to use the calculator, and I explained that earlier today. All right. So this problem 18 is a good problem here. In exercise 17 to 28, use the data on confidence level to construct the confidence interval SMW. In this problem, the confidence level is given, is 99%. Percentage of the green peas, okay? And one of the Mendel's famous genetic experiment, you have 580 peas, that's the N. 428 of them is green and 152 are the yellow. So here they are asking you to find the interval for it. Now, so 580, 420 is the green, 152 is the yellow. How do I calculate percentage of the green? Percentage of the green is p hat The total is 580 and 420 of them are the green, so that give you 0.74. You subtract from 1 to find the Q. Confidence interval is 99%. What is left from the 1 when it's 99%? 0.01. This is the alpha, area of both tails. Area of one tail is you divide by 2, okay? So for that, you could now, we don't really have to go through the table anymore because it's easier to use a calculator. So this area, the tail area to the left, this little ones is 0.05. That's this area, right? So what I do is I go to the second verse, inverse norm, you put 0.005, you don't have to touch this, it give you this number is 2.575. Okay, now you need to calculate margin of the error. Z of alpha half again is this Z here. We already calculate. P hat, Q hat, and the all are given. That give you the value of E. Okay, take the E, add it to P hat and subtract from P hat, that give you the interval here. Now, what I show you here is also you could use your calculator. So in the classroom, we always ask you to find the solutions. But since this is an online class now, you need to find the answers, especially when you do the homework. Calculate, we apply the calculator to verify our answers. So here, if you want to use a calculator, you go to stat, test, look for 1 dash proportion Z interval. They ask for the X, they ask for the N, confidence level is 99%. You do that, it gives you the answer. It's normally very close because sometimes you have to kind of run this. I'll put this table so you understand. Some of the numbers, since they are very, very general, is always here. Now, I talk about the N value, but I just show you the solution of one of the problems. But here I want to work on 2 problems so you understand how to apply the N value, how to find the N value, the number of samples here. Use the given data to find minimum sample size required. See, for this, you have to do the hand calculation. Calculator is not designed to give you the N value. Okay, so for these problems, 31, I have the solution here for you. In these problems, the value of P hat and Q hat are not given. If it's not given, always assume 50%. So if you don't see P hat and Q hat in the problems, always assume 0.50, 0.50. Confidence level was given was 99%. We already calculate for 99%, it's 2.575. In the previous problem, we talked about this. So that Z of half belong to this 99% confidence interval. You have this. In the problem, they are saying this. They're saying the error, margin of the error is 3%, means they are giving you the E value. A statement of the problem say margin of error is 3 percentage point, means they are giving you the E value, 0.03. Because 3%, right? 3% is what? It's 0.03. Okay, you put everything here. Since we are talking about the samples, numbers, it has to be a whole number. So if it's a decimal, you could round it down or up. It doesn't really, in this case, I think it was 41.3 or something. So I rounded up to 42. Part B, they are saying, what if you have 3% margin of error? It's the same thing. And I'm sorry, the E is the same. What they're saying, what if you have on part B they are giving you the p hat. They're saying it's 10%. All right, so if this is 10% or 0.10, Q is 0.90, you put it here, you come up with these numbers. And then part C, they're asking whether there is a change or not. I also did 32, another problem that we ask you to find the number of samples. Very similar to that. So I put two problems here so you understand where and how to use N value. And this one, part A was 90%. So the confidence, the Z value is 1.64. Part B of the problems, it was 95%. So eventually you kind of memorize all these numbers because when you change okay, let me double check on something. Okay, first one was 90%. So it would be second verse. That's 1.64. I'm just trying to check on this. Look, the first one, it said half was 0.05, right? Because it was 90%. So you go to second verse, inverse norm. You put 0.05 because it's half of that. So that's minus 1.64. And then let's go to the second one is 95%. I think this might be different. Second. So the second one is 0.025. 1.96. So here I should put 1.96. Sorry about that. So 1.96. Let me double check on the problems. So this should be 2401. Okay. All right, so that would be end of section 7.1.